All right. Salam, እንዴት ናችሁ? Hello everyone, how is everyone doing? ሰላም ናችሁ ወይ? This is going to be mostly in Amharic for my fellow Amharic speakers who are getting ready to take their AWS certification exam with Developer Associate. So let's do it. እናርግ በአማርኛም በእንግሊዝኛም. It's gonna be both in Amharic and English, but I'm gonna balance more towards Amharic one so it can be a little bit of help to students or learners or like any person who is like me who is trying to get the exam done and getting ready. Okay, let's do it. Let me just double check if it is actually streaming. Okay. ኦኬ እንቀጥል። እሺ ትላንትና የተወሰነ ኢንትሮውን አይተን ነበረ። ፕላኑን ነው የምንሰራው። ዴቨሎፐር አሶሺየት ኤግዛም ፕሪፕ ፕላኑን ነው። ወደ 19 ፓርቶች አሉት። ሜቢ ከወር በላይ ሊፈጅ ይችላል ዝግጅቱ። ግን እስቲ አብረን እንዘጋጃለን። በቀጣይነት ቢያንስ በቀን 1 ሰዓትም ቢሆን በማጥናት እንግዲህ ወጥረን እንይዛለን ማለት ነው። እንግዲህ እንቅልፍ ማጣት ይኖራል፣ ሌሎች ነገሮችን ሰክሪፋይ ማድረግ ይኖራል፣ የተለያየ ነገር ይኖራል። በዛ ሁሉ በርቱ ልላችሁ እፈልጋለሁ። አንዳንዱ ነገር ዋጋ ካልተከፈለበት ለተወሰነ ጊዜ የሚሆን ነገር አይደለም። ከስራ ጋር የምታጠኑ ካላችሁ ከፋሚሊ ጋር ከተለያየ ነገር ጋር ግን ራሴን አሳድጋለሁ ቀይራለሁ ብላችሁ ጨክናችሁ የያዛችሁ ካላችሁ እንግዲህ በርቱ ልላችሁ እፈልጋለሁ ማለት ነው። ስለዚህ እዚህን ታቦችን ልቀንሳቸው። ታቦች ሲበዙ ጥሩ አይደለም፣ አእምሮን ቦታ ይይዛሉ። ለዛ ግራ ከሚያጋቡን ምንም አይሰሩልንም። ከትላንት የተቀመጡ ናቸው። ኦኬ ሌትስ ሲ። ትላንትና ኤግዛሙ ላይ ነበር ያቆምነው። አይ ቲንክ 1-2 ጥያቄ ሰርተን ነበር ያቆምነው፣ ግን ፓውዝ አድርገነው ነበረ። ለዛ ሲሞር እንልና እንቀጥላለን ማለት ነው። ሬዚዩም እንላለን። ኦኬ 20 ጥያቄ ነው። ስታርት እንላለን። ኦኬ ሶስተኛ ጥያቄ a company uses an AWS lambda function to call a third party REST endpoint. Personally identifiable information PII is exposed upon a successful request. The third party that manages the REST endpoint requires the company to change the API key that the company uses to invoke the endpoint every 4 months. The company retrieves the API key by calling an endpoint that the third party owns. The endpoint uses basic authentication, username and password. The new API key is available and active 1 month prior to the inactivation of the old API key. When the company retrieves the new API key, the company needs to store the key for use in future invocations of the REST endpoint. The company needs a secure solution that eliminates downtime while the company sets up the new API key. Which solution will meet this requirement? Guys, ምን እንዳለ ራሱ አላወኩም። ረጅም ስለሆነ ጥያቄው እንጀት ጓደኛዬን እዚህ ጋር ትረክ ላድርጋት ቻትጂፒቲን ማለት ነው። በቀላሉ አስረጅኝ እላታለሁ። ይህ ምንድን ነው የሚፈልገው እላታለሁ። I have እዚህ ጋር ፕሮጀክቶች አሉኝ። ለምሺ okay, let's log out and then I'm gonna log into my own. REST API ይላል because this is like a beginner exam, 20 questions, beginner exam. So we don't have to know everything. It's just showing us what the exam looks like. Now that we're learning, the exam looks like long and connected. That way we have the whole image of, that way we get ready with the whole image. Okay, so I'm gonna copy paste, simplify and ask me clarity or even analogy. ቀለል አድርገሽ ጠይቄኝ አልኳት። እዚህ ጋር ራሱ አስተካክላ እንዲሰጠኝ ማለት ነው። ላስቁመውና simplify and ask me with clarity or even analogies. Okay, let's see. እዚህ ጋር ምንድን ነው የጠየቀን? REST API አለ፣ ላምዳ አለ። let me see ብታነብልን ደግሞ ምን ይመስላታል?
Think of this like a house with a door lock that must be changed every 4 months, but people must still come in and out without stopping. Simple analogy. Your Lambda equals a delivery person. The API key equals the house key. The third-party endpoint equals the house you deliver to. Secrets manager equals a secure key box. Rotation Lambda equals the person who updates the keys in the box. Staging labels AWS current, AWS previous equals name tags on the keys. The company needs a place to safely store the current key. No one should see it lying around. A way to add the new key before the old one expires. Zero interruption while switching keys. Simple answer. Use AWS Secrets Manager with secret rotation enabled. 1. Store the API key in AWS Secrets Manager, not in environment variables. 2. Configure automatic rotation using a Lambda rotation function that calls the third-party endpoint to get the new key, stores the new key as AWS current, keeps the old key as AWS previous until it expires. 3. Your API calling Lambda always reads the key from Secrets Manager. No downtime. Always has the correct active key. No manual changes. PII stays secure. Why this works. Keeps the API key encrypted and hidden. Automates the key swap before expiration. Zero downtime. Lambda just reads the newest key, meets compliance around PII and key rotation. Exam version. 1 sentence. Store the API key in AWS Secrets Manager and enable automatic rotation with a rotation Lambda. Configure the Lambda function that calls the third-party endpoint to retrieve the AWS current secret from Secrets Manager at runtime. Would you like me to turn this into a flashcard, practice question, or a 60-second memory trick?
Okay, don't worry. So ምንድን ነው እየጠየቀን ያለው? Okay, ላምዳ ይጠቀማል ነው። ተርድ ፓርቲ ለሄዶ ኢንፎርሜሽን ለማምጣት ነው። PII ወይም ደግሞ ፐርሰናሊ አይደንቲፋይብል ኢንፎርሜሽን ኤክስፖዝ ይሆናል። እሺ፣ ተርድ ፓርቲው ደግሞ ምን ይሆናል? ኦኬ፣ ይሄ API ኪው መቀያየር አለበት ነው። ምክንያቱም ተመሳሳይ ሆኖ ከቆየ ላምዳ ፋንክሽኑ የሚጠቀመው API ኪ ተመሳሳይ ከሆነ ሌሎችም ያገኙታል በሚል API ኪው በየ4 ወሩ መቀያየር አለበት ነው። እሺ፣ endpoint use basic authentication and activation. ኦኬ፣ አሁን API አዲሱ API ኪ ከ4 ወሩ በ3ኛ ወር ማለት ነው አቬሌብል ይሆናል። ኤክስፓየር ሳያደርግ 1 ወር ሲቀረው ካለ 4 ወር ከሆነ ለምሳሌ መቀየር ያለበት በ3ኛ ወር ሬዲ ይሆናል ማለት ነው። እሺ፣ when the company retrieves the new API key, the company needs to store the key for use in future invocations of the REST endpoint. The company needs secure lock solution that eliminates downtime while the company sets up the new API key. አሁን KMS ሴክሬት ማኔጀር ተምረናል ቅድም። ሌላውስ ምንድን ነው የነገረችን ሴትዮዋችን ማለት ChatGPT? መጀመሪያው ሴክሬት manager. That automatic rotation using lambda rotation function that calls the third party endpoint to get the new key. Okay, stores the new key as AWS current, keeps the old as AWS previous until it expires. Your API calling Lambda always reads the key from secret manager, no downtime, always has the correct active key, no manual changes, PIST secure. Okay, so the answer is store the API key in parameter store. No, I don't think so. Store the API key in AWS secret manager, create a Lambda function to obtain new API key from the third party, configure rotation in secret manager to use the Lambda function to obtain a new, okay, configure rotation in secrets manager to use the Lambda function to obtain new API key. Store the new API key in secrets manager, configure rotation to occur every 4 months. Okay, that's good. Okay, we just only have one option, I guess. Store, C says store the API key in Amazon DynamoDB አይደለም. Secret manager. Okay, store the API key as a Lambda environment variable. Retrieve the new API key from the third party. I think it's B. ChatGPT በተነገረን መሰረት። እሺ correct. API ኪውን secret manager ውስጥ አስቀምጠን ላምዳ ፋንክሽኑ ደግሞ ይሄ ምን የሚያደርግ ከተርድ ፓርቲው API ኪውን የሚያመጣ ላምዳ ፋንክሽን ክሬት እናደርጋለን። ከዛ ሴክሬት ማኔጀሩን ደግሞ ሮቴት እናደርገው እንትን ኮንፊገር እናደርገዋለን። ሴክሬት ማኔጀሩ ተለያይ ላምዳ ፋንክሽን አዳዲስ API ኪዎችን እንዲያመጣ ኮንፊገር እናደርገዋለን ማለት ነው። እሺ ከዛ አዲሱን ደግሞ ልክ አዲሱ ሲመጣ እዛው መልሶ ሴክሬት ማኔጀር ውስጥ Okay, correct. API key rotation, including third-party key rotation with the Lambda function, is available in Secrets Manager. For more information about how to rotate third-party secrets, how rotation works. Third-party secret store, okay. Okay, let's go. But before that, I want to go back and use ChatGPT for the last two questions. Can I or no? I don't think I can, so I should go. ወደፊት መሄድ አለብኝ። እሺ ይሄኛው አጠር የምትል ጥያቄ ናት። A company has an inventory system that receives sporadic inventory update from fulfillment system in the form of large JSON file. Okay, while many files can be sent in a short time period, days can pass when no files are sent. The company wants to process these files as soon as they arrive. Which solution will meet this requirement? Okay. Sporadic ማለት like random ማለት ይመስለኛል። ጄሰን ነው ኢንቨንቶሪ ሲስተም አለው ወይም ፋይል ማስቀመጫ ሲስተም አለው። በጄሰን ፋይል መልኩ አንዳንዴ ብዙ ሊላክ ይችላል፣ አንዳንዴ ደግሞ ምንምም ላይላክ ይችላል። ያ ፋይል እንደመጣ ፕሮሰስ ማድረግ ይፈልጋል። ምንድነው ወዲያው ፕሮሰስ የሚያደርግለት ነው። ጄሰኑ እንደመጣ መጣ ብሎ የሆነ ላምዳ ፋንክሽን ሴንስ ማድረግ አለበት ወደ ኤስ3 ምናምን የሚገባ ከሆነ። ከዛ እስቲ እኔ ምርጫዎችን send the JSON file to Amazon Elastic File System Amazon EFS, configure an AWS Lambda function with an Amazon EFS event source to process the files. Maybe B, send the JSON files to Amazon Elastic File System, schedule an AWS Lambda function to process the file once each hour. It looks like it's immediately as soon as they arrive now. I don't think it's once each hour. Send the JSON files to an Amazon S3 bucket. JSON files, S3 bucket. Configure AWS Lambda function with an S3 event source to process the S3 object. Maybe send the JSON file to an Amazon S3. Schedule AWS Lambda function to process S3 object once each hour. So ይሄኛው እያለን ያለው ወደ ኢላስቲክ ፋይል ሲስተም ላኩት ነው። ከላካችሁት በኋላ ላምዳ ፋንክሽኑ ወይም ላምዳችሁ ልክ ኢቨንት ኤፍኤስ ላይ ኢቨንቱ ሲፈጠር ወይም ይሄ ጄሰን ፋይሉ ሲገባ ላምዳው ፕሮሰስ እንዲያደርገው ኦልሬዲ ኮንፊገር አድርጉት ነው የሚለው። ይሄኛው ደግሞ አንድ አወር ነው። ይሄ ከአንድ አወር በየአወሩ የሚለው ትክክል አይሆንም። ጥያቄው as soon as the files arrive ስለሚል to process the file like እንደተላከ ነው ፕሮሰስ መደረግ ያለበት። ስለዚህ ኤ ወይም ሲ ነው። ኤ የምልበት ምክንያት ፋይል ጄሰን ፋይል ስለሆነ ኢላስቲክ ፋይል ሲስተም ቢሆን ነው። ሲ ደግሞ ምለው ኤስ3 የትኛውንም ነገር መያዝ ስለሚችል ሰው ይሄ ኤ ሊሆን ይችላል ወይም ሲ ሊሆን ይችላል። ከዛ በፊት ነገሩ ላይ ኢንቨስቲጌሽን እናደርግ። ኦኬ እዚጋ በአናሎጂ ምናምን ስለሚያስረዳን ምን እየተፈለገብን እንዳለ ኦኬ እዚህ ጋር ኤስ3 ነው እያለን ያለው።
Nice, this is a classic serverless pattern one. You said, open quote, files come sporadically, bursts plus long gaps. Files are large JSON. You want to process them as soon as they arrive, close quote. Best high-level solution. Use Amazon S3 plus S3 event notifications plus AWS Lambda or SQS Lambda. Flow. 1. Fulfillment system uploads each JSON file to an S3 bucket. 2. S3 event notification is configured. Whenever a new object is created in this bucket, send an event to. 3. The event goes directly to a Lambda function or to an SQS queue first, then Lambda pulls from SQS, better for very high bursts. 4. Lambda processes the file, parses JSON, updates inventory system, etc. Analogy. Think of S3 bucket equals a mailbox. Fulfillment system, delivery truck dropping envelopes, JSON files into the mailbox. S3 event, the mailbox instantly pinging you. New mail just arrived. Lambda equals you automatically walking to the box, opening the letter, and updating your notebook. Inventory. You don't sit outside the mailbox all day just in case, like an always-on EC2 polling for files. Check the mailbox every hour on a schedule, like a cron job event bridge schedule. Instead, you only move when mail actually arrives. That's event-driven, serverless, and cost-efficient. Why this fits the requirements. Sporadic traffic? No problem. Lambda and S3 are fully managed. Nothing runs when no files are coming. Bursts of many files? Lambda can scale out to process many events in parallel or use SQS in between for buffering. Process as soon as they arrive. S3 event, trigger is near real time. No waiting for a schedule. If you want, you can paste the multiple choice options you're seeing, and I'll help you pick the exact right one and explain.
so EFS ለምን አልሆነም ለምንድን ኤስ3 ብዬ ጠይቄ ነበረ። ኤስ3 ቀላል ነው ኔቲቭሊ ራሱ ሴንድ ያደርጋል ኢቨንት ወደ ላምዳ ሴንድ ያደርጋል ነው የሚለው። ከውጪ ደግሞ ከውጪ ሲስተሞች አፕሎድ ለማድረግም ቀላል ነው ይላል። ሰርቨርለስ ነው ይላል። ቺፕ ነው ይላል። አይድልም ሲሆን ቺፕ ነው ይላል። ፋይል ሲስተም ኦኬ ኪፕ ማውንትድ ወይም ተሰክቶ መቆየት የለበትም ፋይሉ ነው የሚለው። ጄሰን ፋይል ኦብጀክት ነው ማለት ነው። ጄሰን ፋይል እሺ። EFS shared hard drive on the network. It's a POSIX file system that you mount to EC2, ECS, or Lambda. Great for apps that need shared read-write access to the same file. Web apps, content management. Legacy. Apps that expect a normal file system storing large libraries or models that use via EFS. But for your scenario, EFS has downside. No native file created event. EFS does not have a built-in new file arrived trigger Lambda mechanism. You don't have to run a polar, example EC2 on a cron Lambda that keeps scanning directories. That breaks the process as soon as they arrived, plus serverless elegance. More operational overhead and cost model. Cost-effective accessory. So for analogy, accessory is a secure post office box that texts you immediately when the letter arrives. EFS is shared filing cabinet in your office. You have to walk over and check it yourself to see if a new file is there. For process files immediately when they arrive with minimal management and great scaling, accessory is natural fit. Okay, so we're gonna do accessory. This is accessory? No, not this one. No, accessory. So send the JSON files to the Amazon accessory bucket, configure an AWS Lambda function with an accessory event source to process the accessory objects. So የመጀመሪያ የተፈለገው ነገር ከጄሰን ፋይሎች ሲመጡ ወዲያው ፕሮሰስ የሚያደርግልን ሲስተም ያስፈልገናል እና ወዲያው ነው ቆይቶ አይደለም። ስለዚህ ምንድን ነው ያደረግነው? ኤስ3 ውስጥ አድርገን ኤስ3ው ደግሞ ወደ ላምዳ ፋይሉ ደርሷል ብሎ ኖቲፋይ የሚያደርግበትን ሲስተም ወይም አይ ቲንክ ኢኔት ወይም ኔቲቭ የሆነ ሲስተም አለው ወይም ሜቢ ክሬት ማድረግ ይኖርብን ይሆናል። አድርገን ቀጥታ ወደ ላምዳ ይልክና ላምዳ ደግሞ ፕሮሰስ ያደርገዋል የተፈለገውን ማለት ነው። ስለዚህ ይሄ ነው ማለት ነው። እሺ ሌትስ ሲ አሁን ምክንያቱም ለምን እንዳለ correct. Lambda functions can be invoked from S3 events and can read from S3 buckets. An event-based invocation would allow for the S3 objects to be processed as soon as they arrive. ለምንድነው ሌሎቹ ማይሆኑት? Lambda function can run on a schedule and read from S3 buckets. However, schedule polling process would not process the S3 objects as soon as they arrive. ፈለግነው እቺ ኪወርዷ ነች ማለት ነው። as soon as arrive የሚለው 5. A developer built an application that stores data in an Amazon RDS multi-AZDB instance. The database performs reads and writes constantly and is responding slowly. Performs reads and writes constantly and is responding slowly. The intensive read requests are received unpredictably several times each year. Intensive read requests are received unpredictably several times each hour. The application cannot tolerate reading stale data. Okay, what is stale data? The developer must increase the retrieval speed of the intensive read request. Which strategy will meet this requirement? Okay, so ምንድነው እየጠየቀን ያለው? እስቲ እንደው ሪፈር እንኳን ሳናረግ ዴቨሎፐሩ አፕሊኬሽን ቢውልድ አድርጓል። ምን የሚያደርግ ዳታ ስቶር የሚያደርግ የት? አማዞን ሪሌሽናል ዳታቤዝ ሰርቪስ ወይም አርዲኤስ መልቲ አቬይላቢሊቲ ዞን ዳታቤዝ ኢንስታንስ ውስጥ ስቶር የሚያደርግ አፕ ፈጠረ። ይሄ አርዲኤስ ደግሞ ምንድነው የሚያደርገው? ሪድ ኤንድ ራይት ነው የሚያደርገው። ከዛ እንደዛ ኮንስታንትሊ እያደረገ እያለ ግን ስሎው ይሆናል፣ ቀስ ይላል። አንዳንዴ ድንገተኛ በአንዴ ብዙ ማንበብ የሚጠበቅበት ፕሮሰስ ማድረግ የሚጠበቅበት ሪኩዌስት ይቀበላል። ይሄ አርዲኤሱ ላይክ በሰዓት ውስጥ ብዙ ጊዜ ድንገት ማለት ነው። ከዛ አፕሊኬሽኑ ምንድነው ስቴል ማለት ስቴል ዳታ ማለት አይ ቲንክ ያልተስተካከለ ይሆናል ግን እናየዋለን። The developer must increase retrieval speed for the intensive read request. I think RDS መጠን መጨመር ይሆናል ወይም ሪድ ካፓሲቲውን መጨመር ይሆናል። ምንድነው ያለን አማራጭ? use Amazon Elastic Cache cluster with a write through strategy. I don't know about write through መሆኑን። Configure the application to direct the intensive read operations to Elastic Cache. Use an Amazon DynamoDB accelerator. Oh, maybe no. Database. No, that's not. Data DB Dynamo እና RDS ይለያያል። ይሄ ነን ስትራክቸርድ ነው። ይሄ ነን ሪሌሽናል ነው። like anything ማስቀመጥ ትችላላችሁ ላይ በቀበትም ዳይናሞ with the write through strategy. Configure the application to direct the intensive read operation to the dark cluster. No, I don't think so. Configure the application to direct the intensive read operations to the multi-AZ standby replica in the second availability zone. This might be the one. And then add an RDS read replica. Configure the application to direct the intensive read operations to the read replica. Multi-AZ standby replica. I believe here multi-AZ ነው የሚሆነው። እዚህ ጋር ደግሞ like same thing ነው read replica ነው ግን multi-AZ አይደለም። So we're gonna check. We don't know. ሁለት አንዱ ይሄ መልስ ባይኖረን አሁን ከሁለት አንዱ ራንደምሊ መምረጥ። እንቅልፍ የመጣ ግን መስራት ፈልጋለሁ። Okay. All right. Let's see. Did we have here? Okay. Okay, guys. Let's see. ይህን እስቲ ያንብብልን ራሱ።
Key facts in the question. Current setup. Amazon RDS multi-AZ. Multi-AZ equals high availability, not a read scaling feature. Problem. Constant reads writes DB is slow. Sudden spikes of intensive read requests. Reads must not return stale data. Strong consistency required. Goal. Faster read performance without stale results. What will not work? Option. Why it fails. RDS read replicas. Replication is asynchronous. Replicas can lag. Stale data risk. Caching Redis ElastiCache. Cache may serve outdated items unless complex invalidation is done. Multi-AZ gives failover, not read scaling. Scaling storage IOPS may help writes but does not solve unpredictable read spikes. Hack correct strategy. Open quote. Migrate the database to Amazon Aurora and add Aurora replicas. Use the Aurora reader endpoint for read scaling. Close quote. Why this works. Aurora replicas share the same underlying storage. Replication lag is typically milliseconds and can be configured for strongly consistent reads when needed. Provides high-speed read scaling. Reader endpoint automatically load balances read traffic. No stale reads if you use cluster endpoint options correctly. Quick analogy. RDS read replica equals making a photocopy of a document. The copy may be a little behind. Aurora replica equals sharing the same original notebook. Everyone sees the same latest page. Final exam style answer. Migrate the database to Amazon Aurora and create Aurora replicas. Configure the application to use the Aurora Reader endpoint for read requests to scale reads without returning stale data. If you want, I can break this into a memory trick or 1-minute recall sheet for exam prep. Would that help?
Okay, so تساس Chalaziga, Malsu Eno. Use Amazon Elastic Cache Cluster with the write-through strategy. Configure the application to direct the intensive read operations to Elastic Cache. Correct. An Elastic Cache cluster with a write-through strategy will allow for the read requests to be redirected to Elastic Cache efficiently. The strategy will allow for the most up-to-date data to be retrieved. The strategy will allow what? For the most up-to-date data to be retrieved. For more information about Elastic Cache, write-through caching strategy. What is caching anyways? Okay. Copy paste gone now. I don't even know what caching is or kind of. Okay. Summarize argele level stimal sunum sastalech. Summarize, simplify, and analogy. Apply to the above question. Okay. Let's see. Is there anybody who's live هنا صار يتكتب يلا. I see 4 people are watching, so let me see. So I can take it serious. Would you comment? Would you let me know if you're actually watching live or if you watched it after, and if it's helpful or how I can make it more helpful, because basically I'm just studying for myself, but I'm sharing along while I'm studying to see if it can help other people who are also getting ready for Developer Associate Exam. I did the AI Practitioner exam study like together, like on YouTube also, and that was super helpful to me. At least I was taking it serious because I was putting it out there in public to see or to just present it to anybody who might be interested. But that helped me to stay focused and to, pass the exam. So let's see. Hopefully, so if you are live, just comment and tell me if you are.
Tash summary, simplification, analogy, apply it to your RDS question. You just pasted 3 cache strategies used with Amazon Elasticache, Memcached, Redis. Let's break them down in plain English and tie them to the previous RDS scenario. Cookie jar analogy. Imagine your database is a big bakery kitchen. Your cache is a small cookie jar sitting closer to you. Fetching cookies, data from the kitchen takes time. So we want cookies in the jar to get them faster. Cache strategies explained. Lazy loading, cache as you go. Analogy. You open the cookie jar. If cookie is missing, you go to the kitchen, bake one, and put it in the jar. Pros, only store cookies people actually want. Cache doesn't overflow. Cons. First request is slow. Cache miss penalty. Cookies can get stale. No automatic refresh. Write through. Bake and store immediately. Analogy. Every time you bake a cookie in the kitchen, you always put a copy in the jar. whether anyone asks for it or not. Pros: jar is always fresh, no stale cookies. Cons: extra work each time you bake, jar fills with cookies nobody may want. TTL: analogy: put cookies in the jar with a timer. After 5 minutes, throw away and refresh if needed. Pros: prevents stale cookies, keeps jar clean. Cons: some cookies may expire even if still needed. Applying this back to your RDS question. The original question, open quote, RDS is slowing down because of unpredictable read spikes and the application cannot tolerate stale data. Close quote. Which caching strategy helps here? Lazy loading might cause stale reads. Write through, writes are expensive and data still misses on new nodes. TTL doesn't guarantee no stale data. Therefore, caching alone is not enough because the question requires, open quote, no stale reads, fast retrieval under read spikes, close quote. That's why the correct strategy was #move to Amazon Aurora and use Aurora replicas. Aurora replicas share the same storage equals almost no lag, ensures no stale data, scales read performance instantly.
So,
Final takeaway.
just gonna wait.
Tash summary, simplification, analogy, apply it to your RDS question. You just pasted 3 cache strategies used with Amazon Elasticache, Memcached, Redis. Let's break them down in plain English and tie them to the previous RDS scenario. Cookie jar analogy. Imagine your database is a big bakery kitchen. Your cache is a small cookie jar sitting closer to you. Fetching cookies, data from the kitchen takes time. So we want cookies in the jar to get them faster. Cache strategies explained. Lazy loading, cache as you go. Analogy. You open the cookie jar. If cookie is missing, you go to the kitchen, bake one, and put it in the jar. Pros: only store cookies people actually want. Cache doesn't overflow. Cons: first request is slow. Cache miss penalty. Cookies can get stale. No automatic refresh. Write through. Bake and store immediately. Analogy. Every time you bake a cookie in the kitchen, you always put a copy in the jar, whether anyone asks for it or not. Pros: jar is always fresh, no stale cookies. Cons: extra work each time you bake, jar fills with cookies nobody may want. TTL, analogy, put cookies in the jar with a timer. After 5 minutes, throw away and refresh if needed. Pros: prevents stale cookies, keeps jar clean. Cons: some cookies may expire even if still needed. Applying this back to your RDS question. The original question, open quote, RDS is slowing down because of unpredictable read spikes and the application cannot tolerate stale data. Close quote. Which caching strategy helps here? Lazy loading might cause stale reads. Write through, writes are expensive and data still misses on new nodes. TTL doesn't guarantee no stale data. Therefore, caching alone is not enough because the question requires, open quote, no stale reads, fast retrieval under read spikes, close quote. That's why the correct strategy was #move to Amazon Aurora and use Aurora replicas. Aurora replicas share the same storage equals almost no lag, ensures no stale data, scales read performance instantly. Final takeaway. Scenario, best choice, must avoid stale data, plus need fast reads. Aurora replicas. Reads can tolerate stale data, plus want performance. Caching TTL, want cheap caching, plus don't mind miss penalty. Lazy loading, want fresh cache always. Write through. Would you like a memory? Stale data means old data that is no longer accurate or up to date. Simple explanation. If your application reads something from storage or cache, but that information has already changed in the database, the data you got is stale. It's outdated. Analogy. Imagine you put milk in the fridge on Monday labeled fresh. By Thursday, it might look fine, but it's not fresh anymore. It's stale. The label didn't update, but reality changed. Same idea in computing. Database got new data. Cache still has the old data. You read the old version, stale data. Healthcare analogy fits you. A patient's medication list was updated in the EMR today, but your printed copy from last week still shows the old.
Okay, number 6. A developer writes an AWS Lambda function in Java that calls a third-party API by using an API key. The developer must keep the API key encrypted and secure from casual observation. The API key can change over time. How can the developer meet these requirements in the most operationally efficient manner? isn't it secret manager again? ምንድነው ጥያቄው? በጃቫ ውስጥ የላምዳ ፋንክሽን ፈጠረ ወይም ጻፈ። ምን የሚያደርግ ነው ይሄ ፋንክሽን? ተርድ ፓርቲ ኤፒአይ የሚጠራ ነው። እሺ ኤፒአይ ኪው ደግሞ ኢንክሪፕትድ መሆን አለበት እና ሴኪዩር መሆን አለበት። ራንደምሊ እንዳይታይ፣ ካዥዋሊ ወይም እንዳይታይ። ኪው ደግሞ መቀየርም ይኖርበታል ኦቨር ታይም። እንዴት ነው ይሄንን ሁሉ ኢንክሪፕሽን እና ሴኪዩሪቲ እና ሮቴሽን ነው እንግዲህ አይ ቲንክ ሲክሬት ማኔጀር መሰለኝና ኬኤምኤስ መሰለኝ። እሺ ሞስት ኦፕሬሽናሊ ኤፊሽንት ማለት ላይ እሱን በማይፈልግ ብዙ እና ኤፌክቲቭ በሆነ ሁኔታ directly in the lambda function program key store the API key in a file on an Amazon Elastic Block Store volume, include code to read the file when the lambda function starts, store the API key in a property file that is deployed with the Java archive, include a code to read the property file when the lambda function starts, store the API key as a source string in the AWS Systems Manager parameter. Store the API key as a secure string in the AWS Systems Manager parameter. Store the API key as a secure string in the AWS system. What is it? Store API key, secure string, system manager parameter store, including code to read the parameter when lambda function starts. I believe it's D. It kind of looks like this, so I was right. Okay, why is it D? Parameter store allows for easy externalization of parameters such as API key. The secure string option provides for data security by keeping the value encrypted at rest. Authorized access to the parameter is governed by IAM permissions. Parameter values can easily be easily changed by authorized principals at any time without requiring redeployment of function, although the function would require intelligence to reread the parameter values. Why don't we just check this with analogy in our friend over here. Oh my goodness. Okay. High level. Oh my gosh. ፓራሜትር ስቶር ልበለው እክሉ ልስጣ ስለ ሴክሬት ማኔጀር ነው የተናገረው። ኦኬ እንለፍ ዋናው ምላሹን ካገኘን እና if we know this is how the exam looks, application that emits data to an Amazon DynamoDB table. The company requires a client-side encryption of specific data items and end-to-end protection for the encrypted data in transit address. Wow, it's like security no እስካሁን. Which combination of steps will meet the requirement to encrypt specific data item? Okay, encrypt የሚያደርግልን ማን ነበር? KMS አይደለም? Symmetric and asymmetric. Client-side encryption into symmetry, generated keys with AWS data encryption. ዝም ብዬ ይሄን ልበላውና ውሽ ያስፈራል። DB table encryption ይሄንንም ዝም ብዬ እያንብብልኝ በልስታ። ችግሩ ምንድነው? ትክክለኛ መልስ ላይ መልስ ይችላል ኮንቴክስት አዌር ስላልሆነ። ይሄን ፊድ ማድረግ ይችላል። I can make an agent. እዛ በኋላ ያሉትን ኮርሶች ሁሉ መስጠት ይችላል። ዋይት ፔፐሮች wait a minute. Okay, OBS Studio.
For client-side encryption of specific attributes in DynamoDB, AWS expects you to use the DynamoDB encryption client, part of the AWS Encryption SDK. This encrypts only selected fields before the data ever leaves the application. Correct choices. Select 2. 1. Use the DynamoDB encryption client in the Python application to encrypt and decrypt specific table attributes before sending the data to DynamoDB. This ensures encryption happens client-side, not on AWS. Only selected attributes are encrypted. Data is protected in transit TLS, at rest, ciphertext in DynamoDB, and remains unwritable without decryption keys, too. Use an AWS KMS Customer Managed Key, CMK, to generate and protect the data encryption key that the DynamoDB encryption client uses. This manages cryptographic material securely, allows controlled key rotation and IAM access, ensures encryption keys never leave AWS KMS unencrypted. Why these are correct. Together, they deliver requirement, solution. Client-side encryption, DynamoDB encryption client. Encrypt only certain attributes, attribute actions, encryption annotations. Data protected end-to-end, TLS plus ciphertext stored in DynamoDB. Secure key handling, AWS KMS CM typical exam flow, memory trick. Encrypt before DynamoDB, store ciphertext, decrypt after get keys from KMS. Not valid by themselves. Server-side encryption, SSE KMS, encrypts whole item at rest, not specific attributes, and not client-side. IAM policies or VPC endpoints, secure access paths but no encryption logic. Final answer. Use the DynamoDB encryption client in Python to encrypt specific attribute values before writing to DynamoDB, and use an AWS KMS Customer Managed Key to protect the encryption keys used by the client. Would you like me to show you a short Python code snippet demonstrating how this is done?
Wait a minute. Where is my Kiro? Kiro? Are you alive, Kiro? My goodness, it's been a while. Let me ask it what it can do. Oh my gosh, look at all my work. Jesus. What was I doing? Wow, I connected it. Gemini. I could bring this here. Small. Okay. በጣም እንቅልፌ ስለመጣ እዚህ ኪሮ ምናምን እያልኩኝ ራሴን ለማነቃቃት ነው። ግን በቃ አንድ ሁለት ጥያቄ እንስራና ይበቃል። ይሄንን እንለፈው በቃ። Developer needs to query relational database from an AWS Lambda function. Lambda function will be called frequently. Developer needs to avoid latency introduced by initial DPC connection to the database and subsequent modification. Be right back. Oh, okay. Developer needs to query relational database. Okay, بدي ألقى هنا. I think we should be done. Okay, developer needs to query relational database from an AWS Lambda function. Lambda function will be called frequently. Developer needs to avoid latency introduced by the initial JDBC connection to the database in subsequent invocation of Lambda function. How can the developer ensure database connection is reused by Lambda? Alright guys, we're gonna finish or continue tomorrow, okay?